Welcome back to Hoffman Tactical. In today's live stream, we're going to be discussing development and the 3D 2A scene, as well as maybe a little bit of airships with a very special guest. And it's someone you may or may not have heard of, but he's been doing probably one of the more interesting characters in the 3D 2A space, and that is Evan Jones. And I'm going to bring him on right now and let him say hello.
Hi, thank you so much for having me on. It's great to be here.
Absolutely. Thank you so much for coming on the show. I think this is going to be pretty interesting. And I look forward to digging into some stuff in basically the development of home-built weapons is kind of the subject we're going to be discussing. So do you want to introduce yourself, let people know a couple of the projects that you're known for that you've been working on?
Sure. So I'm Evan Jones. I've been in the 3D printing space for a while, although I don't have a released product yet. The main thing that I focused on is trying to make a mostly 3D printed semi-auto rifle that has a sort of a very similar scale of do-it-yourselfness to the FGC-9. So doesn't require any machining equipment and very limited use of real firearms parts. So mostly just off-the-shelf stuff and things you can either make yourself with hand tools or print. So the main the main operating system that I've focused on has been flywheel delay. So I've been working on a flywheel delayed rifle for about 2.5 or 3 years now. It's been a very slow project, which I apologize for, but it has sort of been crawling towards hopefully getting finished eventually. YouTube doesn't allow handling guns in live streams, but I propped up the shattered remains of my my most recent prototype in the background.
Yeah, I saw you had a failure with that, a pretty scary one.
Yeah, I had my first case head separation a few days ago. But besides printed guns, I do have some other content that I put on my YouTube channel. I'm a big aviation enthusiast, and I've been working on a home-built airplane that I've been making videos about, although it's been a while since I've released one, unfortunately. Yeah, that's pretty much the main focus of my channel.
Yeah, it's pretty cool. You guys should check it out. I think it's Evan Jones here on YouTube. If you're watching on YouTube, you're also on Odyssey. So if those are on Odyssey, you can check that out as well. He's got some really cool videos, especially on the airplanes. So check that out. Yeah, so the flywheel delayed rifle is kind of more along the lines you're focusing on accessibility. So trying to make something that requires less firearms parts and that has that's basically it's easier for more people to make in more areas that can't get like AR-15 parts and such. That's kind of the goal of the project.
Yeah.
As well as, of course, being super, super awesome and cool. So what are your thoughts on... So I've been thinking about a certain concept more recently, which is accessibility versus performance. So, and this is broader than just 3D printed firearms, but kind of with home-built weapon systems in general, we could be focusing on kind of two different areas. One of them is trying to make things more accessible. So more European friendly, trying to make it so you can build stuff without needing ammunition, without needing as many or any firearms components, as well as trying to make them easier to build or lower cost. So that's kind of one side of the equation. And then on the other side is trying to make things have better capabilities. So that would be like some of the launchers we're seeing done, even though it's difficult developing things like that. But things that have like anti-armor equipment, more automated systems, with electronics in them, guided turrets, maybe heavier dedicated machine gun type weapons, water cooled. I don't know exactly, but kind of focusing more on heavier or more capable weapons that can be used in a broader sense, regardless of how easy or hard they are to make. So I think that's kind of like two different directions we could be going in. And what are your thoughts on that?
Well, I think another factor too that sort of plays into that consideration is also the amount of people that will build something. Like with the FGC9, the number of people who have used Glock barrels compared to the number of people who have who VCM'd their own barrels is very, very different. So that's one big thing to consider is the more you veer into doing as many things as possible yourself, it does sort of, it can lower the number of people who actually complete a gun.
I see exactly where you're coming from there. And I think part of that has to do with the majority of 3D printed gun printers are in the US. So they can get the firearms parts. So they're not motivated to do it all themselves. I know that's the way I am. Like, I'm not super motivated to do a completely do-it-yourself gun just because I don't need to. However, in other countries, they have a lot more motivation to do that because there is no alternative. And I think that's part of it. Definitely. It's here in the US, there's not nearly as large of an incentive to try to do a fully do-it-yourself firearm as it is in other countries. I think that is a good point.
And I think that's, I think a good sort of solution to that is to try and accommodate both different, both different avenues. Like release try and make sure your release can use commercial barrels in addition to ECM if it's going that route.
Yep, I see what you mean there. Yeah, trying to make it so that.
So you definitely can strike a balance between the two.
Yeah, so you try to make it appeal to people who want to get parts kits or get ready-made factory components and make it easier. To try to otherwise the project will not get enough support to really go anywhere.
Yeah, and like ultimately, I think the thing we really want to see is the projects really being out there and being built. So as much as you can do to facilitate that, I think is a good thing.
Definitely. So as far as do-it-yourself firearms go, let's try to focus on European-friendly firearms. So that would be something that's designed to use no firearms components at all, and then ammunition is definitely a factor that is worthy of discussion. Along those lines, what are your thoughts on some of the work that Suckboy Tony has done, specifically related to his semi-caseless ammunition or fragmenting case ammunition that he's been working on? Do you think there's potential there? I've been thinking about it quite a bit recently. And I think avoiding factory-made ammunition is equally as important as trying to avoid firearms parts. So I think that's an interesting project.
The work that he's done is really cool, and he's also a good friend of mine. So I'm really excited to see to see his project released. It's really cool because there aren't a lot of 3D printed designs that are designed from first principles in the way that his is. Since he designed his own ammunition, he was able to keep the chamber pressure really, really low. And so that's why he's able to use completely printed barrels. And it also enables him to use fragmenting cases. So it's a really cool example of a gun that was designed from the ground up in every way to be 3D printed.
It definitely is. So what I would kind of like to see would be a project that uses more metal parts, maybe even custom made, like not even super accessible, but just as a sort of a thought experiment, or just as be physical, not really thought, but as an interesting experiment, something designed around his ammunition or a similar type of ammunition, a do-it-yourself type ammunition, but using a metal lockup system, properly metal rifled steel barrel, all of that. And the biggest issue that comes to my mind, of course, would be trying to use the electric ignition system using the plasma arc to ignite the ammunition, which is kind of the core of the whole weapon system, along with metal components, installation, properly sealing stuff. It all seems to be quite a big challenge. So that's one thing I've been thinking about. And I would really, that's probably one of the biggest, big projects, which I think will be really cool to work
on. When it comes to actions that are very easy to make, with limited equipment. They're usually fixed breech face designs, like magazine fed revolvers or magazine fed falling blocks, which I've rambled about in the past a bit. One of the big problems with those kinds of things that are very inherently strong and easy to make at home is ejection is a bit of a complicated problem. And so that's one thing that that really gets me excited about his fragmenting case ammo, is that you don't have to eject. So scaling his cartridges up and using them in a system like that would be really cool, because it would really lend well to something like that.
Yeah, so speaking of ejection, that is one thing I've been thinking about, is you still need some sort of mechanism for ejection, you know, not every single time, but some way of removing like failures to fire, for an example, which I would imagine would still be a thing. In that circumstance, you'd still need some sort of mechanism to remove the spent shell case. So there are some little nuances there that definitely add some complexity to the system.
Yeah, I actually didn't consider malfunctions before.
Yeah, I didn't either at first, but then I was like, oh, wait, what happens if we have a dud shoved in our chamber? We have to be able to get that out still. So we still need some sort of mechanism to do that relatively efficiently. Obviously, it doesn't have to be the same level of efficiency as a conventional firearm, which has to eject the shell case every single time you fire, but it's still something that has to be done if needed in a relatively short amount of time. So that's another thing to be considered. So how difficult would be if you had just conventional machine tools, you know, a lathe, mill, not anything CNC, so just very rudimentary equipment. How difficult would be some sort of a rotating bolt system? Just the bolt head and the barrel. Like, how much complexity is there? Like, kind of. Well, I'm thinking that a similar system to what the like the Barrett M82 would use. A large rotating bolt, AR-15 style, but they're both the exact same concept. So something like that.
With manual equipment, there would be some somewhat complicated things about it. For instance, the bolt, either the bolt or the carrier would have to have a helix in it somewhere.
Yeah, so that part, my thought process is the carrier could be 3D printed. So a lot of that complexity could be put into the 3D printed part, because that's really not under, it's not under any, certainly not under any significant firing pressure. And with proper design, the stress should be able to be mitigated, especially if you were just focusing on, well, it depends on the circumstances, obviously, but that part could be 3D printed, was kind of my thought process. So the parts that would need to be metal would be the bolt head and the barrel extension and the barrel. So you'd have to obviously have a barrel, and then a barrel extension, which would thread onto the barrel. And then you'd have to cut the profiles for the bolt head and the barrel extension, turn them. And then you'd have to machine the lugs on both components, which I would think would be a lower tolerance cut. But it still seems like a pretty complicated operation. But just thinking about it, it doesn't seem impossible. Like, it seems like something that would be, I wouldn't use the word straightforward, but it seems like something that would be possible. But I haven't seen it done at all, though. So I've been thinking about that as well.
With the manual mill and lathe, you can do about anything.
Yeah, well,
I think
yes, it gets a lot of work, though.
I think there might have been a YouTuber named Gaunt who made a bolt action from scratch with locking lugs.
Oh, okay.
Maybe
he froze up again. We have a connection bug, it looks like.
Am I back?
Yes, you're back now. There we go.
Oh, great.
And it may have frozen up again. No, you're back. There we go. All right. Yeah, you were saying there was a Gaunt, you said? A YouTuber who worked on that?
I believe so. Let's see. I'm looking up his channel.
Yeah, so another thing that comes to mind along the lines of what Suckboy Tony is working on is the bolt face sealing. So in a conventional firearm, obviously the shell casing is the seal that that seals your chamber shut and prevents gas from leaking out around your bolt face. But on something with a fragmenting plastic case, there is no sealing. It's basically caseless. There is nothing there to seal the chamber. So that is a larger problem that I'm not really sure what the solution to it is. I know Tony right now is using like basically a TPU washer that actually just seals it up. But on an all metal firearm that's designed for longer term use, that wouldn't really be practical. So do you have any thoughts on something that could be used to basically seal the chamber on a caseless firearm like that?
Well, so the system that Suckboy Tony is using right now is very similar to the Shoshaw, which is really cool. Or I'm sorry, I had a brain moment. I mean, it's very similar to the Shaspo.
Shaspo. I'm not familiar with that one.
It was the French answer to the Dreisen needle rifle.
Also, no leads.
So there was this tiny little era in the 1870s where the meta was bolt action paper cartridges, and because they were paper cartridges, they didn't have brass to seal, so they had they both had compressed discs of rubber, a lot like Suckboy Tony's system. So it's cool to see, hundreds of years later,
the same system used. Did you do a similar thing? I think we've lost him again. Yeah, so there's this YouTuber called Gaunt who I need to check out, who sounds like he's done some interesting stuff. So Sam T mentions he's interesting as well.
Was I wrong about him making a bolt action from scratch?
I'm not sure. Yeah, so you were saying that the firearms in the paper case bolt action firearms are exactly the same as Suckboy Tony as far as the problems you need to solve. You have no way of sealing the chamber, and you have to figure that out. And they're using rubber washers.
Yeah, I can't think off of my head of something higher pressure that had to seal like that. I guess like really large artillery does, yes. But I'm not sure how what the solution to that.
The artillery is what came to my mind when I was thinking about it. Obviously, the artillery, and then obviously the HK caseless rifles that they developed. Was that HK, or am I thinking of the wrong company?
Oh yeah, the G11.
Yeah, which actually was relatively successful from what I've heard, and it ran caseless ammunition, and it used a rotating cylinder lockup, and I assume they simply just had high tolerances with smooth polished surfaces to help seal it. Basically, it was very similar to a revolver in the way it's sealed, but it would require higher manufacturing tolerances. Because he froze up again, unfortunately. There you are. You're back now. Yeah, okay, you're back. Yeah, so a revolver has a similar problem to solve.
Except they don't actually really have to solve it.
Well, exactly. That's just it. So a revolver doesn't really solve it. They just live with the side blast. So would there be a way of venting the gases appropriately where you don't need to seal it fully? I mean, would that be an acceptable option?
I'd imagine so, if you were able to like completely surround the action. And another gun that would be an interesting thing to look to was Textron's bid for the NGSW competition. It used a sliding chamber and a fixed breech face. And so, of course, it had a gas seal at the front like a revolver. I'm not sure what their solution to that was, other than high tolerances. But that would be an interesting thing for inspiration
to look into. Yeah, it's an interesting problem, and that's kind of like at the heart of the issue when you move to using metal parts. If you want something that's like a longer term semi-automatic firearm that you can fire like 100 rounds with, without having issues. The other problem that comes to mind is with the electronic, as I mentioned earlier, with the electronic ignition system, you're going to need some sort of a spark plug like insulator to to bring the basically to have a wire that goes through your bolt and then to the probe in the bolt face, and insulating that and making that durable where you can fire hundreds of rounds without it failing is also a more perplexing problem, especially for a more do-it-yourself perspective.
You could maybe use like spring-loaded contacts or sliding contacts.
To get it started, yes, that would help convey into the bolt, but just really, I'm thinking more of through the bolt and leading out of the bolt face into the chamber, because it's a high voltage, without having any stray arcs, because you want the it has to be insulated enough where you want it to arc from one probe to the other, however those are arranged, and if it arcs somewhere else, it's not going to have a reliable ignition, if any at all. So that was another problem I was thinking about that would be challenging.
I do remember him talking about how he isolated the plasma thing. I can't remember what he was doing, but I do remember that he had a good, interesting solution to that problem.
Okay. I should, because that's
that would definitely be something to ask him about.
Yeah, I really need to get him on for another stream to discuss this again. But it's something that really, those two issues are kind of seem like the main issues. But even a manually operated bolt action rifle that was designed to fire, that was metal and designed to fire a larger number of caseless rounds would be a really interesting project. Just anything kind of along those lines would be super interesting. So that's kind of what I've been thinking about as far as the trying to make things a little more accessible, trying to make them easier. Basically more accessible, easier to make with less firearms components without using factory ammunition. Have you seen or thought of any other solutions to using factory ammunition that would help, other than the Suckboy Tony's work?
Well, so one thing that you could do that might have a few less technical challenges would be a semi-telescoped cartridge as opposed to fragmenting case. His system works really well, so it probably wouldn't be worth investigating that, but that would technically be another option.
So telescoping case,
mm-hmm.
Is that where the bullet is inside of the propellant, sort of? Or
so when it's in a telescoped case, the bullet is pushed all the way down into the case. So plastic telescope case cartridges, it's just like a plastic tube with really thick walls with powder and a bullet crushed inside of it, and so from the outside it just looks like a little cylinder. The Steyr ACR used semi-telescoped cartridges, although they had weird flechette thingies, and the Textron NGSW bid also had semi-telescoped cartridges, and the thing about them that a system like that would apply really well to 3D printing is if you took like a conventional cartridge and you tried to print it, even if you have really thick walls, just like a Nagant revolver but with plastic, the case would shatter, and you'd only extract a small amount of it, if you could even extract it all. Like most likely the plastic rim would tear. With what systems like the Steyr ACR used, the case is just expected to shatter, and it's extracted with a push rod. So all the fragments just get pushed straight out. And
out into the bore, or out into.
Well, they have a sliding chamber, so out into the environment.
Okay, so I'm having to picture the sliding chamber. I have to look into that more. I'm trying to picture that would look like. Is that like a split chamber? No.
No, it's not a split chamber. It's like a one-cylinder revolver essentially. Think of it like a gate loading revolver with an ejector rod.
Okay, I'm starting to see what you mean. So so kind of like the Nagant revolver, the comment that I just brought up.
Mm-hmm.
I see. Yeah, that is interesting.
So I think that's really the The only other major option for using plastic cases, besides having the case fragment and blow out the bore, is to have a case that have a chamber that's completely evacuated of case fragments and
forcefully with an actual like rod, a plunger that pushes it out. That is interesting.
Another thing that may technically be an option is a conventional cartridge that extracts from the back in the.
I think you dropped that again.
Oh, am I back?
Yep, now you're back.
Sorry about that. I keep getting like dropped periodically.
And I think I think you're back. Okay. Yeah, you were saying there's another option where you can extract a case in a more conventional manner from the rim.
Yeah, you could probably get away with that if you had very, very low pressures and like a very flexible, strong case made out of an exotic filament like nylon or something of that nature. There's a guy who made a printed 577 Snider cartridge that way for a Snider rifle, which is another very cool antique. And it's also kind of analogous to like plastic 12 gauge cases. You could maybe do that, but of course the big challenge you'd be facing there is making a rim that's strong enough, and you're also reducing accessibility a lot because you need an exotic filament. So I think overall either Suckboy Tony's system or aping the Steyr ACR are probably much more promising solutions to DIY ammo.
Yeah, I know Tony has had some very promising results. So that project I'm definitely keeping an eye on. So moving on now more to the, well, I guess, yeah, I mean, that was interesting. So moving on more to the kind of capability side, have you looked at any like high capacity feeding mechanisms? So belt feds or maybe some sort of a helical magazine or something that would be used on a more of a suppressive fire type system for putting a lot more rounds downrange at once. Oh, I think it may have frozen up again. Yeah. Should be back in a second. We have Goombeam in. So, hey, Goombeam. I'm glad you're here. I think Evan is still frozen for some reason.
Oh, am I back?
Now you're back. Yep, there we go. Yeah, it froze up again there for some reason. Yeah, so I was asking about the high capacity type feeding devices. Did you catch that?
Yeah. So I haven't really looked into that much myself because it doesn't really make much sense. Well, that's not the right thing to say. It doesn't really serve as much purpose to have a lot of suppressive fire when you're limited to semi-auto and binary.
Yes, that's why the more capable side is more difficult to develop, because a lot of it is unfortunately illegal. But yeah, I mean, like I use force reset triggers or active triggers now with my new super safety, and obviously that's still a little sketchy, but shooting faster, there are, I think, good options nowadays to do that. And the bigger issue I see is really the cooling side of things, and maintaining the weapon throughout firing all of your ammunition and keeping it in good working order without overheating is kind of is another larger issue.
Yeah. I'm sure it wouldn't be impossible to come up with a quick change barrel system, which is a kind of the solution to that won out with real guns.
Yes, nowadays. So I've been thinking a bit about water cooling actually for like vehicle mounted systems, and rather than using, so I guess a lot of conventional water cooling systems from the past, like on a lot of the like Browning machine guns and a lot of the old machine guns from like the World War I and World War II era as well. They used heavy cooling jackets with a limited amount of water circulation, and they used boiling, basically the water changing phase, the boiling, to cool the system. So I've been thinking something maybe more along the lines of a forced cooling system with a much lower temperature water. So with you have a heat sink on the weapon, which is water cooled, and then that water is then cooled through a radiator and then recirculated, or a cooling system of some type, and then recirculated to maintain a lower temperature. And I'm not sure the feasibility of that, but that's what I've been thinking about for a vehicle mounted system, something that would basically an active cooling system used to cool the system.
Yeah, that would definitely be a strong solution, especially if you have a fixed barrel, because that's one of the things that made cooling on like Vickers guns and Maxim guns and 1919's kind of difficult, is they had reciprocating barrels, so they had to seal at the front.
Exactly. Yeah. So that's a with a fixed barrel system, a fixed barrel closed bolt system, a non-changeable barrel. And the problem with changing the barrel is the rest of the gun is still getting super hot, and then even with being able to change your barrel, using printed components is still very difficult. So using a proper water cooling system would eliminate that issue, and then you could use printed components in a lot more areas without worrying about them being overheated, because the entire system would be properly cooled.
I guess on the subject of belt feds, which I kind of missed, there's a really cool project. I think it's been posted on r/Foscad and Gun at Rust. There's a guy. Oh yeah, that's it. The RBC9.
Yes. I saw that one. I've downloaded. It's been released. I downloaded and looked at it. It's a really cool build. The guy's documentation is ridiculously detailed. Like, he did a really good job with the pictures. So it's a 9mm, obviously. It's 9mm disintegrating link, I believe, striker fired, and it's roller delayed blowback. And he does have a quick change barrel system, which is kind of funny. So yeah, that is that I think is really the only released belt fed we now have. And he was very much focusing on a fully do-it-yourself build. With really, I'm not sure what his solution for the barrel is. I believe he uses an AR9 barrel, so the barrel doesn't have a do-it-yourself solution. I mean, you could make it yourself using the FGC9's techniques, but the barrel itself, he's using AR9, but everything else is like all do-it-yourself, including the roller delayed blowback mechanism, which is super cool.
Yeah, I believe he was machining a lot of the roller related parts.
From what I saw, he was using different sizes of like piping and round steel, and then just cutting, grinding, and he did a little welding. So really yeah, he didn't really do anything precision. He was just getting parts that were the right size and then putting them together. It's on his Odyssey page. It's over here on Odyssey. I should put the link in the chat if people want to check it out. I have to remember where it is, but it's the RBC9. You should be able to find it. He has really, really good docs. It is a pretty complicated project, and it's not super polished or anything, the design itself, but I think it is, it does have a lot. It's super cool that it was actually released. Here it is. I will post the link in the Odyssey chat. I'm going to click this. All right, here is the link. It's in the Odyssey chat. Those of you who are on YouTube, head over to Odyssey and check out the link over there if you want to find the RBC9. It's the current released belt fed version, and I'm pretty excited about it. It's a pretty cool build. Looking at the mechanism, how it works, it is pretty conventional though. So he's using a reciprocating feed pawl feeding mechanism. It's disintegrating links. It's a push through style. So it's similar to modern conventional belt feds in the design.
Yeah, that's really cool that it has a DIY bolt. I didn't realize that about it, so I'm very happy to be mistaken there. This is a lot cooler than I thought it was.
Yeah, I kind of feel like I feel like the project really needs to be broken apart, and the bolt needs to be put into a more conventional non-belt fed firearm, like just the delayed blowback bolt, and it's also striker fired, which is interesting. So that's all a do-it-yourself fire control group.
Yeah, that's really cool.
Yeah, it's a pretty cool build. Yes, I'm not sure why he decided to go with delayed. I mean, I guess he just wanted to try a whole bunch of stuff in one build. It's an interesting mashup of stuff. Generally speaking, I would think blowback would be perfectly acceptable for a heavier firearm like that anyway. But just a whole bunch of really, really cool stuff thrown into a single build. And he put a lot of detail into stuff like the bipod and the sights, which are all 3D printed as well. Like he spent a lot of time designing those little, well, maybe he spent a little bit of time, I don't know, but he did all the little details are all designed out as well, which is also not super typical and pretty impressive.
Yeah, it looks really sharp.
Yeah, it's a very cool build. And I would like to do one. It's a big project, though, as you can tell by looking at it. There's a lot of printed parts there. But I think nowadays, belt feds, especially for like vehicle mounted solutions, though, a belt fed is probably not the best thing to do. Some sort of a helical magazine, even though this is a very contentious point among people who have used helical magazines on small arms, some sort of a helical magazine or a feeding system like that you'd find on a like a aircraft would, I think, be more practical nowadays. And I'd like to see a project along those lines done.
That would certainly be interesting. Honestly, I'm not too familiar with guns of that scale. my knowledge mostly stops at man-portable stuff.
Yeah, well, I mean, so when you think of helical magazines, probably the Calico comes to mind as
or
one.
the Bison.
The Bison, I don't think I've heard of that one.
It's a it's an AK derivative with a helical magazine.
Oh, is that the North Korean helical magazine, or is that it?
Oh wait, no, it's not the North Korean one. The North Korean one is intermediate caliber. I think the Bison, I can't remember where it's from, but yeah, it's a really cool gun.
Yeah, that is cool. I have to check that out. The other one, so there's the other helical magazine that comes to mind, of course, is the one using the Lewis gun. The Lewis gun runs the Lewis gun. It's a lot of actually super cool features, such as the way the Lewis gun ejects. It has basically the FGC9 style ejector, which I think is really cool. It also has an actively driven helical magazine. So it's driven actively, just like a belt-fed belt is driven. And I think that's a very interesting feature.
The air cooling is also really neat.
It is, though I've heard it's not very effective. I don't know. Intuitively, I don't see how it will be super effective. It's cool, but I don't think it would be very effective at getting enough air pulled through the gun. Even with forced air cooling, air is not very good at transferring the heat away.
Yeah, I haven't had any personal experiences with them, but I would certainly love to. It's a very neat gun.
It is, yes. It would be really cool to look one over and run it. But the magazine is, to me, the most interesting part of it. And it uses an actively driven helical magazine. So helical magazines can take a couple different forms. So the Calico, the ammunition is parallel to the axis of rotation. So all of the rounds are basically in the magazine this way, and they rotate out like this, and then they feed out of the magazine basically just like that out of the helix, which is pretty simple because the ammunition is always facing in the same direction. So it makes removing ammunition from the magazine simpler. Systems like on the Lewis gun, and also the one other cool little gun that uses a helical magazine, spring fed, is the American 180, the little 22 submachine gun.
Oh yeah.
It uses a spring fed helical magazine. So, and that one actually appeared to work quite well from everything I've heard, but it was, and even with 22 as well, which is interesting. But I've been thinking something more of the lines of a magazine like on the Lewis gun, and as well as on the American 180. So all your ammunition, the ammunition is pointing towards the axis of rotation. So basically your ammunition is all wrapped around in a helix pointing towards the axis of rotation, which allows for easier feeding, I would say. And you can get more ammunition in a more compact area compared to the way Calico does it. Now, the basic issue that comes down to helical magazines, especially like the Calico, is with the feeding springs. Trying to spring load a high capacity magazine like that, even trying to spring load a drum magazine, results in lots of problems. They're just never that reliable. That's kind of like the biggest issue I've seen.
Yeah, they need like just the right amount of tension.
Yeah, so something I think we have some comments here. Let's see. Simon Claret says the American 180 is a better example since the rotation of the drum is operated by the bolt instead of a spring. So the Lewis gun is operated by the bolt. The American 180 I thought was spring loaded. Though it may also be bolt operated. If that's the case, that's quite cool, because bolt operated this seems like a way better way of doing it to me. And then Eva TB64 says actively driven with a few electric motors on something modern would be like an aircraft gun. Yeah, so that's exactly what I'm thinking. I'm thinking basically a stepper motor driven helical magazine that so rather than having a spring, the helix is rotated by a stepper motor, and then you would have the problem. So the problem you run into is if you're feeding a conventional firearm like an AR-15 or any conventional semi-automatic firearm that's gas driven, the gun is shooting at an arbitrary rate. It's not like if you're shooting something like a minigun, like really any minigun, the ammunition feeding system is tied to the minigun. So whatever the rate of fire of the minigun is, it can feed the ammunition at exactly the right rate to feed it into the system. The entire system is indexed together, right? Which makes it a bit simpler to feed. The problem with feeding something like an AR-15 is you can't do that. You have to feed ammunition at an arbitrary rate. And when you're using a spring, the spring just keeps up with the gun. But if you're using an electric motor, especially with a large helical magazine, which has significant mass, you have to worry about the system has to be able to spool up and then feed ammunition at the appropriate rate and then spool back down again when you stop shooting. And that by itself seems like a pretty perplexing problem. But I think the solution is to use some sort of like a spring buffer. So what I've been thinking is having basically a magazine, like a collapsing telescoping magazine that has the bottom cut out. And then it has like a feed chute that feeds the helical magazine. So that can hold like 20, 30 rounds of ammunition like a conventional magazine would. It is spring driven and it has the same reliability as a standard box magazine. And then when you start shooting, that buffer is able to feed ammunition into the magazine, into the firearm. And then there's a sensor on that buffer that tells the controller that controls the motor how much ammunition is in the magazine. It can detect that you're starting to shoot, and then it will spool up. It'll have time to spool up the helical magazine and start feeding rounds to fill that buffer back up. And then it can balance the speed to keep that buffer full. And when you stop shooting, the buffer will have enough space. It can keep filling up as the helix is spooled back down. Does that make sense?
Have you seen the bullet hose from Suckboy Tony developed?
I talked to him about it, but I haven't seen any specific details. But I'm thinking of that type of mechanism. The feeding chute would definitely be needed to connect a helical magazine to a firearm.
Yeah, that's certainly an interesting idea. One thing I do wonder is why aren't drum magazines an option?
So yes, so I just want quickly, we had a comment here. Yes, we are checking the Odyssey comments, keeping an eye on them, and any good ones that come up, we will be responding to those. So hopefully will pop up on the screen here. I actually have an assistant in the background who is bringing comments up. So any good ones that come up, we should be able to see them and bring up some more comments. If you get good ones, you can bring more up and we'll answer them. Yeah. So drum magazines. So the problem I see with drum magazines is they don't maintain positive control over each cartridge. So the advantage of a helical magazine is because you have the helix is basically a grid of rows running this way and rows running this way, and it's all just wrapped around a cylinder in a helical pattern. Each cartridge is captured in one cell of those two rows make up a grid, and each cartridge is captured in that grid in a super positive way. So there's no way for a cartridge to become misaligned or twisted or jammed because it's super positive. The problem with drum magazines is once you get to a certain size, the cartridges become it's just not as positive, basically, is the way I see it. But I think it does have potential. Sure. Do you have any particular thoughts on it?
Well, I mean, I know they do sometimes get a bad reputation, but there are well-designed drum magazines out there that work really, really well. Like something like a Suomi drum, I think would be pretty reliable, and they really aren't actually that complex either.
No, but the problem is
and
they do have limited capacity, though. I mean, like, what's the largest?
It's a pretty high limited capacity.
For like a couple hundred rounds, though, at most. No, higher?
I can't afford more than that.
Okay, so I'm thinking more along of like one or 2,000 rounds. So something that would
Wow.
provide several minutes of fully automatic fire for heavy, for a vehicle mounted system is more of what I'm thinking about, rather than So that's obviously too much for, unless you want like an Iron Man suit setup. That's like too much for a man portable system. Though that would be cool to have like 1,000 rounds in a big heavy backpack, but I don't think that's very practical. So drums, I'm familiar with the Magpul drum magazines, like the way they work, but I haven't, other than them, I haven't really handled any other drum magazines. That's really about it. So do they all follow
another one that are actually pretty good?
What's the, well, we have a comment here. It's, have you seen the Partisan 9 Mark II, which uses a HK MP5 SD type barrel? I have not. I've not heard of that. What are the details on the project? That's from Colton 25.
Yeah, I've seen the Partisan, although I haven't seen that specifically. I've really fallen behind when it comes to making new designs. I really need to make a Partisan and a new Ratu.
I'm very behind at keeping up with them myself. So, okay, we have a comment from Zeraki. Zeraki, that's how you pronounce it, Zeraka. What about something like the Hill submachine gun? It's like the P90 before FN iterated on the design. So is it just a straight blowback then? Like the P90? I don't know. I haven't. I'm not familiar with that. But the P90 is not that interesting of a design, really. I don't know. There are P90 fans out there. Yeah, so we're talking about AK magazines, drum magazines, and the way they work.
Well, they're just another example of a drum magazine that is a lot more reliable than you would expect it to be from the reputation that drum magazines sometimes get. I think they're definitely an option, not necessarily for something vehicle mounted, of course, but if you were trying to make something with pretty high capacity, it may actually wind up being an easier avenue than like a belt-fed
option,
suppressive fire sort of thing.
Yeah, because belt feds, while they're very, very cool, and I'm a big fan, tend to be the ammunition. Well, let's see, how do I say this? They're very complex. It's well, they're actually not that complex, but it's a significantly increasing in complexity, including the belts and the links and all of that. And there's a lot more avenues for malfunctions and reliability issues without a giant advantage in firepower. In how many rounds you can. It depends on the configuration, but Beltfeds is kind of a lot of cost to pay for the extra performance you're getting compared to a magazine fed system.
It can certainly be worth it, but
definitely, but
not as much for us where we have to make the whole thing.
Yeah, it definitely adds complexity. So to the background, people working back there, definitely bring up some more comments for us. We have quite a few comments here. We want to bring up some good ones, and we'll look them over. Here we have another one from Colton 25. It's the Partisan 9 has holes right after the chamber, bleeding gas and making all 9mm subsonic, and has an integral suppressor. Okay, so it's an integrally suppressed system.
That's cool.
I remember
the first time I saw an integrally suppressed barrel. I was so shocked. Like, this, it's got holes in it. How does this hold pressure? How does this work?
Yeah, I'm not even sure myself how they work, because it seems like you're killing your velocity. I don't know. They're very interesting. They're very interesting. Let's see. Yeah, and so speaking of that, have you seen the it's not the Matador, it's a new, relatively new company. They make uppers. They have their bufferless uppers. They make an AR-15 they make a 5.56 piston piston operated. I believe it's a short stroke piston operated, but they also make a 9mm upper. They're kind of big and boxy. For a while, they weren't. I think they weren't selling the uppers separately. They were just selling the uppers and lowers. Do you remember the name of that company?
Oh no, I hadn't seen them before.
Who was that? I was talking to them about Vin about them. Vin did a lower for them. I don't know. It's terrible. I cannot remember the name. Anybody in the comments can think of what I'm describing. Let's see. So Photon from Odyssey mentions Hill submachine gun. That's I think that was mentioned earlier. That is some sort of a submachine gun project. I don't know. But the gun I'm thinking of, whatever it is, it's a really very, it took me like a few minutes looking at it to figure out how it worked. It's a 9mm, and it's really what I would call the only true delayed blowback I've actually seen. And the way it functions is it's a 9mm that is a short stroke gas piston operated, but from all appearances, looking at it, the piston is only used to unlock the bolt. So it's got a 3-lug rotating bolt. So like it locks up, it fires, and then the port is just after the chamber. So it's like maybe my camera. Let me turn my camera back on. We started recording. We don't want to do that. The gas port that goes to the piston is only like maybe a 1/2 inch, 1/4 inch out of the chamber. It's really, really, really close to the chamber, and it goes to a little tiny gas piston it's a little tiny short stroke gas piston that just barely bumps the bolt carrier. It bumps the bolt carrier enough where it just unlocks it, and then conventional blowback can take over and then just blow back the rest of the way. So that is a really interesting system that I haven't seen anywhere else. And
sorry.
Do you follow what I mean? Like how that works?
Yeah. So that's a system that is called retarded blowback, and it's described. It's not commonly discussed, but it's described in George Chin's book called The Machine Gun, which is a really cool resource. And so with retarded blowback, basically all the piston does is unlocks, and the actual operation of the bolt is done by residual chamber pressure. The only example that I knew of before now was the 20mm Hispano Suiza autocannon that was used in some World War II aircraft. So that's really cool to know that a very strange and archaic system has made a comeback.
Yes, and I wish it's this company was kind of all over the place back when they came up with their stuff, because they were making a bufferless 5.56 short piston upper, and everybody loves those. The name is on the tip of my tongue, but I can't think of it. But yes, they make a 9mm variant. They don't talk about it anywhere about how it works. And looking at it, I was like, this is really strange. This is like a gas piston operated 9mm. But when you actually start looking at how it worked, but then there was no gas piston. You couldn't see any gas piston because it was so short. It was buried under the base of the handguard where the barrel nut is. So it was very interesting. So retarded blowback is the official name. So the terminology for like the different types of blowback is very confusing and like pretty twisted. It's kind of funny.
Yeah, well, it's kind of inconsistent in a lot of ways.
Like the MP5, I would call more of it's more of like a leverage or mechanical advantage type of system. Like it's giving the bolt. It's not so. The descriptions I always had of how the MP5 worked was that there was rollers, and they added friction, and that slowed the bolt opening until the gas pressure was lower, then it opened up fully. But the way it really works is it's more like, and I'll check this coming out just a second. The way it really works is the rollers act to give the mass of the bolt carrier and the weight of the string a mechanical advantage over the bolt.
Yeah, and it's accelerating the carrier just like lever delayed blowback accelerates the carrier.
It's exactly the same.
They're not detents. They're much more than that.
Yeah, exactly. So it's roller delayed and lever delayed are actually exactly the same as far as the physics of how they work. There's no difference. I mean, they obviously are different mechanisms, but they do exactly the same thing. They're just giving
the same principle.
Yeah, so it's basically if the mechanical advantage was 2-to-1, it's the same as having a bolt that weighs twice as much and a spring that's twice as heavy until until the rollers pop out and it's that zone of the bolt's movement is completed, and then you restore your standard bolt mass and spring weight, and that allows the bolt to fully cycle to the rear and rechamber. So it's more of a mechanical advantage issue than a delay. There's no real delay there. The bolt starts opening as soon as you fire. So that's why I would think the retarded blowback is more of a true delay, because there's actually a delay there before the piston starts to unlock it. So it's kind of like if I was starting to name it fresh, I would call a roller delayed and lever delayed system, I would call that retarded, or probably that would be a better word. And I would put delayed for the retarded. I'd swap the terms around. It would make more sense. So it adds a lot of confusion.
So the best explanation that I've ever heard of came from a really small little channel that has a really cool video that I think a lot of you guys would enjoy. It's called Cabinet of Curiosities, I think. And he had a video where he described an attempt to make like a Lorentz force delayed blowback. And I think the root of things is there's always something that delays the opening happening. In simple blowback, the delaying force is just mass. Like you could call simple blowback mass delayed blowback. But then again, so if you want to be like really super pedantic, everything is delayed in some manner. And I think the root of why retarded blowback is called what it is because the blowback stage of the cycle is retarded. It's moved to a different time.
It's moved to a later period. It's delayed until later. Retarded and delayed kind of mean the same thing. They actually they're kind of the synonyms actually. They're actually synonyms pretty much. That's pretty funny. That's an interesting way of looking at it. So Colton 25, and I think we may have missed the comment I might want to bring up here, but the Colton 25 says, I'll bring this one back up. Eva TV 64 says, retarded blowback is what the HKP7 and Alien pistols uses.
So the Alien is just gas delay.
So describe gas delayed versus retarded.
So with gas delay, it's always blowback operation. There's no point where the breech is locked, but that the blowback is delayed by the direct force of a gas piston pulling the bolt forward.
I see. So it's I see actually. Yeah, I know what you're talking about. It's a really weird system. So that's what the Alien. It's a strange system. Okay, that makes sense. So Colton 25 says the VP22 is a pretty cool. It is based on the British Wellrod pistol. It's a magazine-fed, manually cycled, suppressed 22 LR. That sounds very esoteric. I've not heard of that one. I guess it makes sense if it's suppressed. The MP5 SD was designed to shoot supersonic ammo at subsonic speed to be as quiet as possible. Okay, that's you're back. You think you froze up for a second there. So Woody Pride is talking about the MP5 SD. It was designed to slow down subsonic to subsonic speeds. Sounds like, I guess, that makes sense if you want to use the same ammunition for everything. Okay, I think this is a good, yep, I was about to bring this one up. There we go. So Simon Claret has a great question. What's your opinion of lever delay blowback, I guess, versus other methods of blowback? And this is something I've been thinking about, is like lever delay seems like it would be, if done right, it would be a lot easier to implement than roller delayed, if you could figure out how to properly implement it. So what are your thoughts on lever delayed blowback? I think Evan is frozen up again. He should be back in just a second. Yeah, so lever delayed is something that it's exactly the same concept as roller delayed blowback, except you're using levers, and it actually intuitively makes more sense than using rollers, because the rollers are sliding on tapered surfaces and the levers are pivoting, and there'd be less friction, less wear. However, the levers would be under a huge amount of stress, and that would be a challenge compared to the rollers, which are just in compression. Oh, it looks like Evan's back. So we have this comment here wondering about lever delayed blowback.
Well, so I think lever delayed blowback is would be a lot more complicated to make than it sounds like at first, because the accelerator bar that accelerates the weight in systems like the FAMAS, it hinges on the receiver. It's got a little leg that like sticks out into a pocket, and so you'd need.
Looks like he froze up again. And the accelerator bar is basically the lever in lever delayed blowback. He's frozen up again.
Oh, sorry about that.
There you are. Audio's back.
And you'd also have to be able to precisely machine that little pocket. So you'd have to come up with a very different system than how lever delayed blowback has been implemented before. I think one thing that you could do is you could put the bolt and the mass in like two separate tubes, and the accelerator bar would just be like a linkage that like pivots about the receiver instead of wedging against it, which a plastic receiver probably could hold up to. But then you have the problem of like this whole secondary receiver that that has a big mass in it that probably has a lot of travel, and like cramming that into a gun would be really hard. I actually did make some like sketches and stuff trying to come up with a system like that before I settled on flywheel delay, and I couldn't think of a way to make it gun shaped.
Interesting.
Maybe you could come up with something different, but you would have to do something pretty weird to get lever delayed viable with DIY.
Yeah, and then and as you mentioned with those receiver pockets, one of the challenges is all the force has to be carried between the levers, and basically between the levers and the barrel. That force has to be carried by the receiver. So you're putting a lot of force on a receiver, and that makes it more challenging. Like on the MP5, they have the barrel extension, which takes all of those loads, and which makes it relatively easy to work with for printed uppers. But with a fully do-it-yourself system, that wouldn't be so much of an option. So that's definitely a large challenge there. We have a comment from Odyssey, from here to print. It's, have you seen the gear delayed buffer system? You know, I think I did. And it's a similar concept to lever delayed. It basically is lever delayed, I believe, but it uses gears to accelerate the mass backwards faster than the bolt itself moves. I don't really know any details on it though, or I've never seen one in action or anything. Have you heard of that, Evan?
No, I haven't. I've also seen a magnetically delayed AR buffer too. There's a lot of weird AR buffer things out there. They're pretty funny.
They are, yeah, and of course the problem with trying to do anything with the AR-15 And I think there was one where they cut pockets in the buffer tube, like 4 rollers, like they tried making it roller delayed blowback. The problem, of course, is you're putting your delay mechanism way back here and your breech is way up here. And you're putting all of that stress between your upper and lower receiver, which isn't really a super good. All the forces are basically being carried by the takedown pins. And I don't know. It's like you're putting a lot of additional stress on your upper and the upper lower junction. So I don't know how well that would work with a printed lower.
It's not delaying the actual operation of the gun. It's delaying the final little bit of bolt travel to try and make things smoother.
That's on the magnetic one.
So the roller delayed one is active from
yeah. Well, it was actually trying to make it roller delayed. This was an article or a page I saw someone experimenting with it. I think it was actually a company experimenting with it. Yeah, it was actually roller delayed blowback. And I think it worked somewhat.
I didn't realize that. That's insane. I love it.
It is. It's pretty insane because like you're retrofitting it way back in the rear. And one of the big another challenge that comes to my mind is you on like the MP5, the mechanism is right there, right by the breech, and that allows for the bolt itself to be super lightweight, so you can help keep your bolt mass down, which is kind of the overall objective anyway. The problem with trying to do that on like an AR9 or on an AR15 style setup is if you're putting everything in the buffer tube, you have like 5 or 6 inches of actual bolt which is just sitting there, and it's going to have mass to it. So you have all that mass out there, which is part of your bolt and not your mass, which is inside you want the bolt itself to be as light as possible, and then the bolt carrier in your buffer tube to be where all your mass is. That's kind of the point of the system. So it's not optimized for that when you're using the AR pattern rifle. So that's another, I just don't think there's a huge amount of potential there. Oh, and we have Mr. Snow in the chat. He is here on YouTube. Before we address Mr. Snow, over here in the Odyssey chat, Potato Doughs says, maybe were you talking about the Per Run upper? I believe that's what it was. The Per Run X15 or the Per Run X16. Does that Per Run? Does that ring a bell?
Oh, not for me.
That's what it was. It was the Per Run. It was the Per Run 9mm upper receiver. I'm pretty sure, about 90% sure that's what it was. That was the retarded blowback 9mm upper that they're making now. It was the Per Run. And they also make a 5.56 version, but it's just conventional. It's not retarded blowback. So Mr. Snow says he mentions the Mean Arms roller bearing delay. And I've actually had a chance to look at that a couple different times now. And Mean Arms is making, it's an AR9 bolt. And this is not what I was talking about. I was talking about something separate. So this one actually, I think it works quite well. It has quite a bit of potential. They're just trying to reduce the recoil of an AR9. And they're using a very much MP5 style roller delayed system, but instead of using rollers, they're just using balls, just basically ball bearings to act as the rollers, and they're putting it all inside of like a conventional form factor for an AR9 bolt. And it just, I think you have to replace the barrel and you have to replace the bolt carrier group, and it turns your AR9 into a roller delayed, or in this case, ball bearing delayed blowback system. My problem with it is it has a lot of really tiny parts, and there's like a lot of little, like very fine parts up front, but it's a kind of a cool project. Have you seen that one?
Oh no, I hadn't seen that before, but that sounds really interesting.
Yeah,
except for the price tag, Mr. Snow mentioned.
The little tiny parts, hence the price tag. It kind of all goes hand in hand. Yeah, it's an interesting project, but it's like, I don't think it's going to go very far, just because it's a little too. The price, it's a little too esoteric. The price is not really worth the increase in performance compared to other 9mm systems you could get, such as the Montego, such as the Per Run 9mm, which did have actually very little recoil. It was quite cool. The Per Run. Per Run, I guess it's how you Per Run is how you're supposed to pronounce it. It's a weird logo. Whenever you come with a company name, got to make sure that it's easy to pronounce. All right. Yeah. Per Run. All right. So let's see. I don't think we missed any Odyssey chats over here. We actually don't want to miss those. All right. Perfect. All right. So we're about a little over, we're a little over halfway through the stream now. And we've covered kind of the more do-it-yourself stuff. We've talked a little bit. I wanted to talk a little bit more about belt feds, I guess, before we moved on. So I guess you haven't worked or looked into belt feds too much.
Oh, no, I actually know very little about them.
Yeah. Oh, and Mr. Snow is here again. It's super fascinating. There is also an interchangeable ramp for the bearing delay to tune for use with suppressors. Yes, they have the profiles of the ramps or the wedges that adjust how much mechanical advantage you have during that delay period are adjustable. So I mean it is a cool product. It's a cool thing they've developed. It's just I mean it's cool. Yeah, no doubt. Yeah, it just costs $1,500. So it would be interesting to experiment with. So, okay. So, Bakal, I'm terrible with these pronunciations, says that Perun means lightning in the Slavic languages. And it is a European manufactured part, upper, I believe. So I guess if it means that in Slavic, that makes sense. But if you're trying to appeal to the American market, you might want to make it a little more American or easier for us simple people to pronounce. Okay. So the only belt fed stuff I've worked on is I have one of those little belt fed 22 uppers. It's one of the Lakeside Razorbacks. The little it's an upper for your AR-15 that takes like little cloth fed belt 22 long rifle cartridges. You've seen those. Have you seen those? Yeah. They're so it's actually quite simple, and I like to do a 3D printed version. The problem is number one, making the belts. Like 3D printing the links of that at that tiny scale, I think is possible. I gotta look into it some more, but 3D printing the links is tricky, and the little fabric belts would be a terrible pain to manufacture. And you can't buy them anymore. None of it's made anymore. They're super expensive to get them used. So that's the only belt that I actually have, and I've had a lot of reliability issues with it, which basically failures to fire. There's a lot of issues that I have, strangely enough, been basically unable to solve. But the belt fed project I've looked into doing is I like to make a belt fed version of the Orca, and the goal would be to use conventional AR-15 parts for the bolt carrier and the buffer. So basically just all still conventional AR-15 parts, and then just make all the belt fed parts 3D printed, and just a few, just use metal screws and pins and stuff. Trying to minimize any custom machine parts. So I have a pretty solid concept worked out, and I printed some little prototypes, but I have to still integrate my prototype feeding mechanism into the Orca, and that's going to be a super big job. So I kind of have pushed that off now. But let's address this comment. The belt fed 9mm is amazing. That's the RBC9. I know you hate PCC, but belt fed is amazing. Yeah, I agree. No. In this case, I give 9mm. In the case of the RBC9, I give, if that's the right, I think it's the RBC9. I give 9mm a complete pass. If it's belt fed, you just get your pistol caliber carbine ticket checked off right away. You're good to go. So I have no problem with 9mm in that context. Resin. Mr. Snow says we've had good success with 22 LR belts using resin printers. Mussy had a 22 long rifle crank design in the works. Interesting. I should. If you could send me the details on those printed links, Mr. Snow, let me know. I'll take a look at them. That would be interesting. I've just been having a lot of trouble getting the little Razorback upper to cycle fully and have enough strength in the hammer to properly fire it. It's been I think there's actually a head spacing issue with it, and the rim is not being properly supported. So it will not fire unless you have a very heavy hammer spring and basically a full weight hammer spring. And that's too heavy for it to reliably cycle, which is unfortunate. But yeah, I'll definitely have to look at those resin printed links. Let's see. D something says maybe use the forward assist grooves and the bolt to drive the belt feeder. Yes. So actually, I have a pretty mature concept developed, and my thought was to use something like for the belt feeding mechanism, rather than try to use the more modern conventional Paul and cam design where you just have a feed pawl that kind of ratchets and pulls the belt in, using something like the early Maxim machine guns. He used a feeding drum that rotated and fed the belt through. So I think that would be something that would be easier to 3D print rather than trying to use cam pawls. We have a question from Kyle here. He says, do you guys have 5.56 headspace gauges or just send it? I have headspace gauges, but with factory equipment, I check it about half the time. It's normally not a huge issue. But yeah, never, as Colton25 says, they're never a bad idea. So
I don't believe in headspace gauges.
And for the work you're doing, I don't know how much good
when I built my first AK, I used the painter's tape trick for head spacing, and I pressed the barrel with the hammer. I protected the muzzle with a giant stack of pennies taped to it, but yeah, I supported the trunnion on the horn of an anvil, and I pressed it in with a 3-pound mini sledge and check the head spacing with painter's tape, and I can make hits with that rifle at 200 yards despite the horrible things I've done to it.
So the head spacing came out pretty good.
Yeah, I think it's probably on the tighter side of wrong, which is good.
Yeah, I have the same question, Kyle. He says, please elaborate on painter's tape method.
Well, so painter's tape is usually about 2,000s thick, I believe. And so you can sort of make your own redneck head spacing gauge by taking a cartridge and putting two pieces of painter's tape right on the case head. And you can get pretty close like that if you don't value your fingers very much, which I don't.
That's interesting. Interesting way of doing it. I had not heard of that before. So jumping back into the Beltfed, K9 Rocket Technologies is here. I'm glad you're here in the chat. He does some interesting stuff with quadcopters, and I don't know if you see him on Twitter. He does interesting electronic
Twitter
stuff.
Page.
Yeah, he's done some interesting stuff. He's just curious to see if a reliable 5.56 printed belt set is possible. Seems like round spacing would be challenging. So the biggest challenge I've had with my design is the bolt geometry of the AR-15 is not designed to strip rounds off of belts. It's designed to strip them out of a magazine. So basically what I've done to try to get around that is I've had this feeding drum, and they're all up in the bin. I have some prototypes printed. They're not in reach, but I have a feeding drum that feeds the belt. The belt comes around the feeding drum and then is presented to the bolt right here. And the entire feeding drum pivots up and down like this, and it's spring loaded. So it basically simulates a magazine. So one of the biggest issue I had was, well, not the biggest, but a big issue is on a conventional belt fed, the bolt travels well beyond the ammunition. So like on some of the earlier Maxim guns and such, basically the bolt comes back and then it over travels. And while it's over traveling, it feeds the belt through, and then it strips the next round off the belt and fires it. And then it comes back, and then as it over travels, it feeds the belt through. And the reason that's important is because you can't feed the belt at the same time you're stripping a round off, obviously. So on the AR-15, I'm stripping the round off on the forward stroke. I can't feed the belt on the forward stroke, which is the conventional way of doing it. On modern, so I'm trying to think, actually, my mind's gone blank for some reason. On modern belt feds, the belt is advanced. Let's see. Jeff Top Gun has a question here. Feeding drum functions like a feeder delinker on the M134. Yeah, so kind of like the M134. Yeah, so you have a sprocket that feeds the belt through. Looking at one of the older earlier prototype Maxim machine guns would probably be a better example. But yes, kind of like the M134's delinker, the minigun delinker. So what I've done to try to get around those issues, which I've kind of poorly described, but what I've done to get around them is I have the bolt goes forward, strips off the round, chambers it, fires, and then as the bolt comes to the rearward motion is what indexes the drum. So that's opposite. Most modern machine guns index it on the forward motion, and I'm going to do it on the rearward motion. And the reason that works is because the feeding drum is spring loaded, so as it rotates, it can pop up and down as needed underneath the bolt carrier group, and then when the bolt comes all the way to the rear, it'll pop up, and then it can strip the next round off. So I'm kind of simulating a magazine, and I have to do that to work around the geometry of the AR-15 bolt carrier, which is and bolt, which are designed for feeding from a standard box magazine. So that's kind of the challenge, but I think it's possible.
That's a really cool system.
Yeah, I have a bunch of. I should send some. I have a bunch of. I have like 5 or 6 pages written up on it, and I just have. It just it can be a lot of work to implement. So I haven't. I worked on it a bunch just to prove the concept, and then I've like worked on other stuff now. So we have another question from Bakel. I find the resurgence of old gun operating systems in 3D printing fascinating. It really feels like early 20th century gun industry in a good way. Yeah, it is really interesting. Kind of like all of this stuff has already been done, so we just have to do enough research to find it and then redo it.
Yeah, another cool thing that's similar is it's sort of a new frontier in a similar way to how autoloaders were a new frontier right at the turn of the century. Or actually a bit before then, because like there's all these firsts out there that haven't been done yet, and like just a regular guy who doesn't have an engineering degree can do them. Like there's all these low-hanging fruits out for the taking. Like that's so rare in engineering. Like
nowadays, that's really rare.
Yeah, there's not many things left to do that are achievable, but in 3D printing, there's this whole field that hasn't been tapped out yet. It has that same sort of pioneering spirit that firearms development back then had.
Yeah, that does make it interesting. So there's definitely it's niche enough and the legal and political things surrounding it make it so it's very attractive for just individuals to work on as opposed to large companies.
Yeah,
large companies
competing against like Guac or
yeah, exactly. They don't have really any incentive to get involved in it. So yeah, so that's the Beltfed, and then the one other thing is to feed it the feeding mechanism. And this is what I guess was mentioned earlier. My concept for the other challenge is getting motion off or taking basically a power takeoff from the AR-15's bolt carrier to drive the belt feeding mechanism. That's the other challenge. Like machining a cam, or I don't want any modification to any of the AR-15 parts. Like I don't want to have to modify any AR-15 parts. So my idea is to try to put a plate between, and this part will probably have to be metal, but a plate between the AR-15's bolt, the end of the bolt carrier and the buffer mass. And then that plate will go through the side of the buffer tube, because on the Orca, the buffer tube's printed, so I can cut a slot in the slot if I want to. And then that plate will have a access bar that comes down the side to a reciprocating rod, and then as the bolt carrier group reciprocates forward and backwards, that plate is trapped between the buffer mass and the bolt carrier group, and it reciprocates, and in turn it moves that external reciprocating rod forward and backwards and transfers that motion forwards to the feeding mechanism, where it will run in a cam track to index the belt feeding sprocket. And what's really cool about that, if you saw the sprocket, the way it works is the sprocket can really only be made via 3D printing, because it has a helical cam track inside of it, and it's something you can't really machine. It would be really hard to machine. You'd have to either mold it somehow, which would be pretty difficult, or 3D print it. So it's kind of cool. It's like a part which can really only be made with 3D printing, and that I always think that's kind of cool. It's like unique to 3D printing. So that is an interesting project.
This is probably more on the insane side of ideas, but have you thought about driving like a a cable with the bolt carrier group. That would be one way you could get power transmission from it.
How are the cable?
You would probably have to tap it, or maybe like use one of the screw holes for the gas key. But
the cable, how are the cable attached, like to the bolt carrier?
Like a bend it around and crimp like wire ferrules to it.
Oh, I see. Yeah, that would be interesting. The problem though would be removing but the problem then is if you want to remove the bolt carrier group for maintenance, it would make it more tricky. Yeah. So that's why I really want to leave all the AR-15 parts just totally unaffected. So you can disassemble the weapon conventionally and take everything out. So that's why I was thinking of putting a plate behind the bolt carrier group that gets pushed to the rear by the bolt carrier group, and then the spring would push it back forward again. And since the power stroke is the rearward stroke, it would be very positive. It would just get pushed back, and then the external reciprocating rod would reciprocate back and forth. Like it would be, the way I'm visualizing it right now is that reciprocating rod would be below the ejection port and would run all the way from in front of where the normal AR-15's magazine well is, all the way back to where the buffer tube is. And it would just reciprocate back and forth and transfer that linear motion. So we have a comment. Let's see. Okay, well, we'll get TH600 Mike is in here. He says, I would create a ratchet off the gas tube, then drive a pinion/gear to translate that into a perpendicular motion. That could work. The problem is the complexity. So I think I can avoid that complexity by just using a power takeoff plate. I mean, that could work, but yeah, it adds complexity. So that's a challenge there. Okay, so we have Wild Arms Research and Development here in the chat. So I'm super glad you're here. A lot of really interesting work. Obviously, Evan, you're very familiar with him, I'm sure. Mm-hmm. He says, my next project is going to be a hypervelocity rocket, but was going to scale the original design down to a non-NFA caliber to prove concept. That would make a cool new round. Think gyrojet. That is actually super crazy. Super crazy.
Please do it. We need a 3D printed bolter.
Especially in a sub NFA caliber. A 0.48 by 10 inch rocket with a 0.12 tungsten penetrator traveling at 4 to 5. Is this 4 to 5,000 feet per second? Is this even possible? Like, do you think that's even possible to do? A rocket that small going that fast with that much mass? I mean, that would be incredibly awesome.
4,000 certainly would be. I'd imagine 5,000 probably would be too.
That's really.
But you'd be generating a lot of heat at that velocity.
Yeah, this is going to. I don't know. I don't know. That would be a very, very interesting anti-armor weapon. Yeah, that's going to be a very cool project. I'm very much hoping you work on that one. Okay, so Colton 25 is back. He says, is Evans' flywheel rifle still in 4570, or did he switch to 450 Bushmaster or 458 SOCOM?
Well, unfortunately, I switched from 4570 to 450 Bushmaster about a year ago. I was really, really reluctant to do that because I'm very attached to 4570. It's really neat because it has so much history behind it, and the project certainly doesn't have as much ring to it now. But it's something that I really had to do. It turns out the very thin wall thickness of 4570 cases turned out to be a really big problem. 4570 has really abnormally thin cases as sort of like an artifact of how old it is. Mm-hmm. Like original 4570 cases were actually made out of copper. And even back in the period, they were known for sticking in chambers. Like I think actually at like the Little Bighorn battle site, they found like trapdoors with cases stuck in the chambers.
Oh, really? Wow. That's interesting.
And
so moving to 450 Bushmaster simplified things quite a bit.
Yeah. With 4570, those very thin case walls really did not were not compatible with delayed blowback because the case is being extracted under a lot of pressure. So they were ballooning and stretching to just a crazy degree. And even after full length resizing, they weren't actually they weren't actually fitting in chambers very easily anymore.
Wow.
And I had someone reach out to me. He has a really cool channel called Dom's Workshop, and he'd experimented with the 4570 autoloader. I don't know what operating mechanism it used, but he said that he was having problems with stretching too. So when I heard that, I decided I really just needed to throw in the towel and switch to a different cartridge. And
I think 450 Bushmaster would be easier to get nowadays too.
Yeah, it's very difficult to get 4570 now. It's really exploded in price since the virus happened.
Oh wow!
At its worst, it could be as much as $80 a box. Now I think it's down to like 60, although I haven't checked too much. Of course, that would be a surmountable problem if it was reloadable, which I thought it would be. Like my original plan for the rifle would be that people would be able to get like a $20 Lee hammer loader and just reload cartridges and not have to worry about the price. But since the cases were irreparably stretched, it just didn't make sense.
Yeah, didn't make sense for that. Okay, so I'm going to change my battery. I'll jump right back. I think we'll shift gears. Well, we'll answer a couple comments. So bring some comments up when I'm back. We'll answer a few comments. I think we have some good ones in here, and then we're going to jump into our final subject, I think. Or maybe we'll add one extra subject in there. We'll see. I'll be back.
But another thing, too, that's been nice about switching is it is very nice to be able to use AR-15 magazines. Like the magwell that I have right now is actually one of Hoffman's magwells. I just took the STL for the lower and butchered the magwell out of it. And like even though my magazines were sort of kind of working, it's just nice not to have to worry about that, to have one less thing to solve. So that's another little side benefit of switching. I do wish I could have used 458 SOCOM, because 458 SOCOM was actually developed using 4570-400 loadings of 4570 as like a basis, which is really cool. That's a neat little historical thing, but that little bottleneck it has is just too much of a pain to deal with. I want ECM chambers. 450 Bushmaster was really the only good option.
Yes. Okay. So let's bring up some comments now, and I think we had a couple good ones in here. Let's see. We had, of course, TH600 Mike says they have a fantastic ratchet mechanisms for under $20, millions of cycles. Yes. Cheap gears. Yes. So I mean, mechanisms like that are, and in fact, you're using gear systems in your flyback rifle. You're using, I believe, a gears with a rack and pinion. So
yep.
Definitely an option, but I mean, it is added to complexity. So if it can be avoided, I think if you can do a simpler way, I think it should be. Let's see. All right, zinc alloy bullets.
Not to my knowledge.
Has anyone tried casting bullets out of zinc alloy? I haven't heard of it. Zinc is a very light metal. A zinc alloy would be like a zinc lead alloy. What would be the advantage, I guess?
It seems like it would be fragile too.
Yeah, it's normally it's normally a pretty low performance, like a zinc copper alloy, but I don't know why you wouldn't just go with, I mean, that would be basically like a brass bullets. Let's see. Okay, here is a good comment, and this kind of leads us into the next subject from Colton25. It is, how's the airplane going, and when will we get another video on it? This is what I've been waiting for. Well,
unfortunately, over the past year or so, I haven't made a lot of progress on it. I've unfortunately had to spend a lot of time on college. It's been my senior year as a mechanical engineering student, and I just wound up having a lot less time to work on projects than I used to, but I have I have been back in the saddle a little bit lately. I've I've been working on trying to get the center section and cabane of the airplane done, and also the carry throughs for the spars in the bottom as well. So essentially, all the wing related stuff that pertains to the fuselage. It'll be a while until I have a video on that. I've had some delays because I changed the diameter of the spar carry throughs to a different size of steel because I was getting a little bit nervous about the stuff I originally bought being too heavy, and so I'm gonna have to recut some stuff. But yeah, I definitely am still working on it. I refuse to give up until it's either done or but yeah, unfortunately, I apologize for the long delay between airplane videos. I'll have another one eventually.
We are looking forward to those. So I guess that leads to the next question, which is, what are your thoughts on lighter than air aircraft?
Zeppelins are certainly very cool, but
not just Zeppelins, but anything lighter than air. I'm very open.
But that's a side of flight I'm not super knowledgeable about.
Very interesting. So have you ever done any like hot air ballooning, gas ballooning?
Oh no, never.
Really, I haven't either. I want to. That's interesting. Yeah. So the rigid airships are definitely a very interesting subject. I mean, even blimps are a really interesting subject as well. It's a lot. They're actually quite complex. But there was obviously when you think of airship, what's the first thing that comes to mind?
I guess the Goodyear blimp.
Okay.
When it comes to non-rigid things, that's the first thing I think of.
And then as far as rigids, probably.
Oh, definitely Graf Zeppelin.
Okay, excellent. That's an excellent answer. That's a pretty educated answer. So you obviously know something about them. The uneducated would of course say the Hindenburg, but that's the Graf Zeppelin was a very successful rigid airship with an excellent flight record.
Zeppelin also made a lot of fixed wing aircraft during World War I, which is really cool. One of my favorite planes ever is the Zeppelin Stockin. It had a 44-meter wingspan. I think its wingspan was actually wider than a B-29. It was one of the biggest planes in the world at the time. Imperial Germany had this whole R-plane program they called them, where they made these absolutely massive bombers for bombing. I think they only really bombed Great Britain, but yeah, that's a very underloved airplane. That's really cool.
That is actually, I don't think I've heard of that one yet. Yeah, that is interesting. Let's see. All right. Yeah, that is interesting. I've mostly looked at obviously they're lighter than air. They're lighter than air equipment. And there was also it was like the something Fredericks company. I forget the name. There was another
Friedrichshafen.
They were another. They made all wooden rigid airships. Early World War I.
I didn't know about that. That's amazing.
I need to find the name of it. It's relatively easy to find if you do a little searching. I forget the name of it. Yeah, so they made all wooden rigid airships. And the sad part is there's very little details. Like I haven't even found any particularly good books on the subject that cover their airships. I guess the problem with them was when they started using them in the war is they used a lot of adhesives that would delaminate in moist ocean environments. So they had a lot of failures due to that. So they eventually moved to using aluminum like the Zeppelin company did.
Have you heard about the USS Archon?
That's one of the. Is that how you pronounce it?
I thought so.
I thought it was the Akron. Yeah, certainly I have. So was the Akron of course, the USS Los Angeles was the first large US, and that one was actually made in Germany, and they shipped it over here. And then there was the Akron and the Macon. Those are the two large Navy helium fields. And of course,
it's so cool that an airborne aircraft carrier actually existed at one point in time, even though it barely worked and crashed. It existed at one point.
Well, so it worked quite well. The problem was they were using this gas called helium, so they were like too scared of using it. So they locked their, closed their vents, and then they burst they burst the gas bags because they overpressurized. That was, I believe, the Macon. I'm not sure if it was the Macon or the Akron.
Didn't they have some trouble with recovery? I thought they found it to be difficult, but I might be misremembering.
Gas recovery of the gas
of the planes.
Oh no. So I think they did early on. Yes, they had an issue with the hook mechanism would seize up under flight, and they couldn't get it loose. I think actually there's a picture of it. They had like two guys had to like climb down there and like down while they're flying and manually get it loose. But they fixed that, and it actually worked reasonably well. They had a lot of they did a bunch of drills over the Caribbean, I believe, and it worked quite well once they got the bugs worked out. The big problem back then was they didn't have all of the electronic control systems we have now. They didn't have all of the guidance systems. So controlling the airship, balancing all the gas pressure, and doing all that manually, as well as avoiding bad weather, was quite challenging. So they would end up getting into sticky situations that they couldn't recover from. It's kind of a big part of the cause of the crashes. But yeah, those were both very cool, very, very interesting airships that ended up both crashing. I think Evan has. Are you still there?
Yeah, I'm still
okay,
here.
You're good. Okay, I thought you froze for a second there. Let's see. All right. So we have any more good comments coming through? So a big issue with airships is just the cost, of course, because they're so big, especially rigids. And then blimps have a lot of their own problems. I'm personally not a huge blimp fan. Like, if you're going to build an airship, it needs to be rigid, is my view of the matter. But on a lighter note, no pun intended, a gas balloon. I think gas ballooning is a really interesting subject that could be very low cost. So hot air ballooning, obviously in this country, is pretty popular, but hot air ballooning has a pretty limited flight duration. It's noisy, and the envelopes wear out relatively quickly, and the envelopes are absolutely enormous because hot air is still actually quite heavy as opposed to a proper lifting gas like hydrogen. So hot air ballooning is quite popular, but gas ballooning is not nearly as popular as it used to be, or it never really was that popular, but it's not grown at all, which is very unfortunate. Simon Claret says, what about a one-person rigid, like a paddle boat for the sky? The problem is rigids don't scale down well. So blimps don't scale up very well beyond a certain point, and rigids don't scale down very well. So it just gets very difficult. Single man, I've looked into it. It's expensive no matter how you look at it. I think a spherical rigid airship strictly for recreation would be super interesting, like a 30 or 40 foot sphere, composite structure, like a geodesic, or probably more of a Goldberg style sphere, using that's basically a sphere made out of pentagons and hexagons, mostly hexagons. Rigid sphere with gas bags internally would be really interesting. There was a project done by, and I cannot remember the name. I can't remember any of these names, but have you seen? You probably haven't. It's a spherical blimp, basically. It was a project in the early 2000s. It was.
I don't think so.
It's a big white ball. If you research or look for a spherical airship and then just look, you'll see it in the images. It has a couple of propellers on each side. So what makes it interesting is the way a normal blimp works. A normal blimp has the gas bag, which holds the lifting gas. And then, so TH600 Mike says a 3D printed geodesic airship. That's kind of what I'm thinking. Not entirely 3D printed, but 3D printed joints. Certainly, I'd like to make a small one, like just a little, like 8-foot diameter one, but I need space for it. Just a little model that would be cool. Let's see. And so I think we have some good comments in here. Here's D something says, do I know anything, or does anyone know what the legality of 950 JDG is? So I've not heard anything about it. And
I think it has a sporting use exemption.
is it a shotgun, or is it like one of those really special?
I think it's like a big game cartridge.
Okay. Yeah, because it may or may not have it. If it does have an exception, then it's the same as shotgun ammunition. Okay. Simon says it's exempt. And it's a huge rifle. Okay, that's interesting. I had not heard of that before. Black powder. So it's one of those like old elephant gun styles.
I thought it was relatively modern, but I don't know much about it. If I had to guess, I think it's smokeless, but I'm not sure.
Yeah. And then let's see. Yeah. Basically a cannon. That's yeah, at that size you're getting into the cannon territory. And then we have a troll in the house. He says you're going to kill yourself with hydrogen off. So hydrogen, as long as you take the proper precautions, it's actually quite safe. So no, hydrogen is the only option, actually. Let's see, and we have let's see, we had one more comment here. Let's see. Yeah, basically a cannon. Yeah. Okay, so what's interesting with a spherical airship was that a conventional blimp has a gas bag on the outside, and then internally it has the ballonets. That because as you go up and down, air pressure changes, so the volume of the airship has to change. So you have to have the ballonets to adjust for that, and the ballonets are filled with air. The way the spherical design worked, and there's a bunch of I found all the patents on it and stuff, so it's pretty well documented project, and it basically turned a conventional blimp inside out. So the outside was a shell that held air, and it was pressurized. The sphere was a pressurized hull, and then internal to that was the gas bag, and the gas bag would just basically float at the top of the sphere, holding everything up, and it was able to expand and contract as needed. And that design simplifies a lot of the valving needed. To compare to it's simple ballonets can be more complex to properly operate. This system is a lot more simple, so it's actually quite attractive as far as the simplicity goes. And another interesting part of it is your gas bag is not subject to the atmospheric environment. So your gas bag, which is the part that has to be completely gas tight and everything, is able to be much thinner and lighter, and it's able to be less expensive, I guess I would say. So it could be a more economical solution. So it's just a really interesting project. It's probably one of the most interesting airship designs that's been done that I've seen. And it's spherical, so you would think it has really bad spheres have pretty poor aerodynamics, but he used a system where they put a propeller on the back of the sphere to try to maintain the laminar flow further back to achieve significantly lower drag. So the numbers they never published the numbers on it, but they had an interesting system.
Like boundary layer ingestion?
Yeah, exactly. So it was like a boundary layer extension system almost. So they had a propeller on the rear of the airship of the sphere that would, I'm not sure exactly how the mechanics of it worked, but it would extend the boundary layer so that the boundary layer would continue further on the sphere, and you'd have a lot smaller vortices at the trailing behind you. It just reduced.
There's some. Oh, sorry if I'm cutting you.
Not at all. Go ahead.
My connection's all weird. There's one aircraft out there. I can't remember what it's called, but it has a very bulbous sort of fuselage, and it has its propeller is right at the end of the empennage, and it actually ingests the boundary layer flowing over the fuselage, and that helps keep it from separating. It's kind of like boundary layer suction, like on an F-104 wing, but for a fuselage. I'd guess the propeller on that spherical blimp is kind of doing a similar thing.
Yes. It's similar to that, and because the drag on a sphere is pretty bad compared to like your coefficient of drag is, and so this is something we have a comment here from a good comment from TH600 Mike. He says tennis ball fuzz is actually quite effective for magnets. That wasn't it. It was let's see. It was on. Let me find this one here. Golf balls and tennis balls are all about pressure control with the boundary layer. So, golf balls have the little dimples on them and all of that. So that's because the coefficient of drag of a sphere, like if you just like look it up, it's generally accepted to be 0.5. But that is only at low Reynolds numbers. So the coefficient of drag of a sphere at higher Reynolds numbers drops off like pretty precipitously, like all the way down below 0.1, below basically 1/10. So it gets that's pretty low especially for a sphere. And then as you go back up, it kind of goes up and asymptotes around like 0.2. So very, very large spheres have significantly better coefficients of drag than small spheres. So what they do with golf balls is they're trying to they're trying to change they're basically trying to simulate a higher Reynolds number to get down into that trough where they have a much more attractive coefficient of drag. The problem with airships is you're already so big that you are way past that trough and up into the area where you asymptote. So no amount of dimples or anything will help with large, really anything larger than 6 feet in diameter, and it's not going to help. But it is an interesting subject. Drag on spheres. Yes, Evan should definitely help me build an airship. Yes, you need to drop the fixed wing thing and move into airships. I agree, actually. Absolutely. 100%.
The limited knowledge I have is all in fixed wing stuff, unfortunately, but I'd love to help however I can.
Yeah, I'm the opposite. I've done a lot of airship research, but I haven't. I've done model airplanes, but that's about it. So quite a few models in the past. Yeah, so there was actually a Magnus Effect airship prototype done. It was quite big too. They had like a 30-foot sphere. It's a bad idea. I mean, it's just there's no way to make that work well. Man, got the theories of flight. Thanks for the suggestion, YouTube. Oh, did Jeff Top Gun just find us? I hope you're here to stay. Yeah, so I guess a few closing. We're getting here near the end. Let's see. Let's scan through the comments and see if there's any good ones. That's to my assistant in the background. So a few closing questions, I guess, would be: how did you get into airplanes? Like, did you do models as a kid, or like how did that work? How did you start building an airship in your backyard? Not an airship, an airplane in your backyard.
Well, I'd pretty much always held an interest in flight, pretty much as long as I can remember. So there wasn't really like a specific start for me. And I'd also found World War I to be a very interesting period for a long time. It is as well. But the thing that really made me decide to start building is there's a forum out there called the Aerodrome. It's very small, and unfortunately, it's a little bit more dead now than it used to be. But for some reason, I stumbled across it, and it's entirely dedicated to World War I, and it has like a sub forum for replicas, and it's really like the biggest community for replica builders specifically. And I stumbled across that one day, and looking through build logs, it sort of demystified things for me. Like I had like the realization for the first time that building an airplane in your garage is something that you really can do. I think I could do this, which looking back on it, I was a bit foolish back then. I probably underestimated it a little bit, but hopefully I still will actually finish it eventually.
Yeah, that would be very cool. Let's see. We have a question here, I think. Another question. Ivan, I was thinking about, this is from, they call me Nightmaster. Ivan, I was thinking about your flywheel concept and was wondering if it would be possible to make a recoil delay system using a one-way wheel dampener.
Like
what does that
that
look like?
applies friction?
I don't know exactly.
One thing that I do think I may end up incorporating into the rifle is a one-way bearing, like a spread clutch. I have had a little bit of problems with the bolt not wanting to return to battery, and so I think adding a one-way clutch would be a really good thing to do just for safety because of that. I'm not sure if that's quite what you mean, but yeah, I do hope to do that at some point in the future. I am a little bit worried about the strength of a Sprag clutch. I'm not entirely sure if it's really going to be as strong as I need it to be, and I'm also very worried about slip. So most likely, what I'm going to end up doing is I'm going to try and cram it into my current system without changing it too much, and so that way, if it doesn't work, I can just go back to my old flywheel. But yeah, experimenting with the Sprag clutch is definitely something I'm going to try out.
Interesting. So I have a one question here on Odyssey I should address. Let's see. It is from let's see. There it is. It is Hoffman. What do you think about semi-rigid lifting bodies? And I assume here it is. Yeah, I assume it's referring to basically a hybrid airship where you have like a blimp or a rigid, doesn't matter, that gets a certain portion of its lift. Basically, the weight of the aircraft is supported by buoyancy, and then the weight of so it's that neutral buoyancy when it's empty, and then once you fill it with load, whatever that is, your cargo, the cargo is then lifted via aerodynamic lift. And the advantage of that is you have it's an airplane with better fuel economy, kind of. And there's a bunch of theoretical studies done, and it does have some advantages from a fuel efficiency standpoint, potentially. It's a lot higher efficiency than a conventional airplane. And then the advantage it has over a conventional airship that derives all of its lift from just static buoyancy is that it has a way better ground handling because you're flying at higher flight speeds, and your wing loading, you actually have some more significant wing loading, so you're able to fly it like an airplane, and you don't have the problems you have with ground handling that you have with conventional airships. My problem with it, though, is the attraction to me of airships is that you're floating through the air. You can shut the engines off at any time, stop moving, and just be silently floating there like a balloon. I don't know. To me, it kind of defeats the purpose of having an airship. So I'm not super interested in hybrid lifting body airship designs. I think it should be either an airplane or an airship. If you're in the business of airships trying to make it profitable currently, that's a kind of a bad idea. I think that airships do have potential, but right now it should be focusing more on just the interest of it. I don't know. That's my interest. Just kind of, I like airships. So, all right. Big thanks to Hoffman and Evan, whoever is reading all the comments. Yeah, thanks for tuning in. We're pulling up to the end here. I'll let you sign off in a minute here, Evan. I'm trying to see what other stuff we might have in here. Clutches. What is the ballistic coefficient of a blimp is the question here. So I know what I'm familiar with coefficients of drag and like the mathematics behind it and stuff. But as far as ballistic coefficients, why is a ballistic coefficient different than the coefficient of drag? Is it because it's supersonic, or why is that done differently with bullets?
So I'm not too familiar with that side of guns, but I thought ballistic coefficient had to do with like the cross-sectional density too.
It might. I don't know. I don't know either. I actually don't know.
Me neither.
The coefficient of drag of blimps, like a smaller Goodyear style, some of the older Goodyear blimps is probably around 0.05 on the high end, down to something larger like the USS Los Angeles would have been like 0.025 or 0.022 0.02 to 0.025, and then something like the Hindenburg would have been even lower. I'm not sure exactly what that was. There are some really interesting papers done on doing deacceleration tests and the different drag coefficients and stuff on some of the back from the 20s on the coefficient of drag of blimps and airships. It's quite interesting, but they do get quite, with optimized body profiles, the coefficient of drag does get quite low, especially as you get into higher Reynolds numbers. It's pretty interesting.
So I Googled it, and ballistic coefficient is mass divided by drag coefficient times area.
Oh, wow. Okay. So it's taking the cross-sectional density into account.
Yeah, so it's like how much mass can you move for a certain amount of drag?
That kind of makes sense. That is interesting. A blimp has to have an extremely low ballistic coefficient because of its sectional density. Stuff is super cool. Yeah, that's true. Actually, the ballistic coefficient of a blimp would be very, very different than a bullet. Let's see. Straffy says, have you looked into the Turner carbine style tilt/side locking mechanisms?
I hadn't actually heard of that before. That's interesting. I'll have to look that up.
Turner carbine style tilt/side locking mechanisms. I haven't heard that either. Yeah, and Simon Claret said it's based on mass, so he had it right. Yeah, cross-sectional density. Okay, very interesting. I think we've got the Odyssey ones covered. Odyssey questions. So I think it sums it up for this video. Let's see. We have one more here. Semi-rigid lifting bodies. We already covered that. We already covered that comment, so we can just grab that one. Okay, perfect. Yeah, so there's still a lot more mechanisms I'd like to talk about. We've covered a bunch of stuff. I think we covered some good stuff today, but there's just there's so much to this subject. I think it's really interesting, especially more of like the do-it-yourself firearms and the more novel mechanisms, which we haven't really seen used in recent modern times, kind of making a comeback is pretty cool. So that is interesting. Jake Smith says, I appreciate all the work you do, Hoffman. Keep doing the work, other guys, keep the segment alive. Yes. So thanks, Jake. We'll stay around. Keep working. Davey J says graphene is the new super material, but I mean, we'll have to wait a couple years to see where it really goes with actual accessibility and performance in the real world. TH600 Mike, he's glad to see other people out there using their brains to create. Yeah, it's the only way of doing it. So otherwise, you probably won't get very far very fast. All right, Evan, do you want to let everybody know where they can find you?
Yeah, so my YouTube channel is just my name, Evan Jones. I think the handle is Evan Jones Project. So that's definitely the place to watch my videos. I've also got an Odyssey backup, and I also have a Twitter account too. Although I don't post all that frequently. Thank you so much for having me on. It's been a really fun night.
Definitely, Evan. It's been very interesting. We've covered quite a bit. I think it's been a good stream. I hope everyone's enjoyed it. For reference, in the YouTube chat, I have dropped the link to Evan Jones' channel in the chat. I would very much recommend. He doesn't like spam you with videos. He actually does way less videos than I think most of us would like to see. But definitely check him out. It's worth subscribing. He's working on some very interesting stuff, and you won't regret it. So I definitely highly recommend you guys jump over there, check his videos out, and subscribe, and definitely follow Evan's work. That is very interesting, and he's also on Odyssey. Yeah, so thank you everybody for tuning in. I hope that we caught most of the good questions here, and I hope you guys enjoyed this stream. I think it was a decent stream. We had probably about 50 people watching on YouTube and like 30 on Odyssey, which is a ratio, which is pretty good. So everybody out there on Odyssey, thanks for tuning in out there. That is the place to be because we're probably only going to be on YouTube for so long. So with that said, everyone, thank you so much for watching, and I will catch you guys again later.